Job to get here. Now, the agenda for today is basically to look at exam revision, and if you haven't already done so, please go to Piazza and look at the questions there. I've got myself ready to look at the questions that have been posted on Piazza. If you have other ones, then feel free to raise them, but I'll preference the ones that are already there, okay? So now let's get started with some admin. First of all, oops, it says raw marks should be available this week. That's actually not correct. The raw marks will be available within 2 weeks of you submitting it. So that's 2 weeks from last Friday. So let me just, sorry for that typo, that mistake. There we are, all good. And you're going to get your feedback pushed to your repo. Now, there was some question about whether Javafx is going to be in the exam. Yes, Javafx is quite possibly in the exam, and I think you'll see that from the practice exam. There's an example there. Another typo, one-to-one consultations. Actually, I need to double check this, and the dates there are wrong, but we're going to try and, sorry folks, I messed up this, this slide here completely. See, it says Tuesday, sorry, this is totally wrong. Monday. And one-to-one consultations available. We're going to keep making one-to-one consultations as long as we can. I'll talk to the tutors and I'll see if I can make them available next week. If I can, I'll post that on Piazza, okay? So, although at the moment it's not for sure that they're going to be next week, I think it's quite likely that they will be, but I'll check with the tutors whether there is enough availability for that. And also depends on your demand. If you guys aren't using the one-to-one consultations, then we won't run them. But if you are, then by all means, we'll absolutely run them. So if you have something to say about that, like you could perhaps put a post at the bottom of the exam revisions post on Piazza and just sort of say, hey, I'd really like to use the one-to-one consultations, and just make a post about that there. And that will help me gauge as to whether it's worthwhile. I don't want tutors to be sitting around for 9 hours each week and there not to be much by way of questions. But if you have questions if you want to utilize that, please let me know, and by all means we'll provide it. CELT, this is the feedback mechanism that the university runs. It's really important, folks, for every course you do, really, really important. We use these things to help us gauge how we can improve classes. We use them both in the positive and negative sense. We look for things that are really positive and say, hey, the students are really enjoying this, or they're really getting a lot out of this, or they're learning this really well. Let's do more of that, and also for the negative. So for things that look like aren't going so well, we've got to ask questions as to why that's not working and how we can improve it. So we really appreciate you taking this seriously and being thoughtful about it, and thoughtfully entering your feedback. Now, onto the exam. So we're going to start off with this review lecture. I'm just going to show a couple of slides. I'm really not going to use slides very much at all. I'm really just going to jump to Piazza and start looking through the questions and start looking through the practice exam. Okay, so this is a silly quote from Woody Allen. But the point there is that if you're engaged, not so much showing up, but if you're actually engaged with the course, if you've been engaged with it through the semester, you should not be stressed about this. You'll be okay, all right? So engagement is the key thing. If you've gone through the course and done the exercises and so forth, even if you feel like you haven't done them as well as you would have liked, you're going to be okay. And the next slide's a little bit relevant, and this is from Feynman, great scientist. I'm not going to ask you to memorize anything. As a matter of fact, the exam is open book. The exam is open book, okay? You're not allowed to get help from anyone. Okay, that's completely unethical. You can't get help from anyone, and that's not allowed. But you can use resources. It's an open book exam. You can look stuff up, okay? You can look stuff up. That's because I do not want you to sit there memorizing junk, okay? But there's a giant caution with this, okay? Now listen up, everyone. This is really important. I don't know if you noticed this in semester 1 or what happened for you all in semester 1, but something I noticed. Remember, I've taught this. This is the 10th year that I've taught this class. Now, I was very surprised last year when I taught this class that I made the exam the same level of difficulty as the previous year, except I dropped one question, and that was partly because of the pandemic. There were a bunch of reasons, but so I made it out of 90 instead of out of 100. And I added 15 minutes to the start. Instead of having 15 minutes of question time, I just made the exam 15 minutes longer. So it's 3 hours and 15 minutes. So that sounds like I've made the exam easier, right? So I've made it shorter and I made it slightly longer in the sense that you don't just have reading time, you can actually read and write for 15 minutes. So what do you think happened to the results? And I made it open book. Okay, so I made it, I gave people more time, I had less questions, and I made it open book. Okay, so it's good. People are going to get better marks, right? And the cohort was good students. What happened, to my astonishment, is the students actually got worse marks than the previous year. I spent a lot of time trying to work out why. And my supposition is, and I've talked to a lot of other people, educationalists and so forth, my supposition is a lot of students thought, oh, the exam's open book, I don't need to study at all. I'm not going to study for this exam because it's open book. I can look everything up during the exam. That's not going to work, folks. You can't try and learn an entire semester's worth of work during the exam. Okay, so absolutely you can look up syntax, you can look up how to open a file, the syntax you need in IntelliJ or whatever. That's fine, right? That's all available to you. You can look all that up. But each time you do that, it slows you down. So the more fluent and the more comfortable you are with things, the better you're going to go. All right? If you have to look up from first principles, how do I solve a recursive problem and try and study it and learn it during the exam, you're not going to answer the question in time. Okay? So please understand this. I think it's something many people are not used to doing open book exams, and you need to understand that an open book exam doesn't mean you don't need to prepare. You do need to prepare, and it will test your fluency with things and your depth of understanding of things. Okay? And please understand, I did not make the exam more difficult. You can see the exams, they're actually online. You can all take a look at them and judge for yourselves. The exam was not more difficult than the previous year, but people actually did worse when it was open book. And I think that's because people didn't understand that you actually need to prepare for an open book exam. All right, so please take that seriously. I'm not going to, like Feynman says here, I'm not going to test you on memorizing facts and figures. Meaningless, but meaningless in the real world and meaningless in an open book exam setting. Okay, but I do expect you to understand stuff. All right, now Leo, can you just yell out if anyone has any questions on the chat about anything relating to the exam or any strong preferences about, and folks, just put it in the chat. If you have a question about the way the exam's going to run or anything like that, please jump in. My plan for today, unless someone yells out something different and on the chat, unless I get something different on the chat, my plan for today is to quickly give an overview of how the exam works, just the mechanics of the exam, very, very quickly, because you can do that later. I'll just quickly give a sketch of that. And then I'm going to start answering the questions that I saw on Piazza, starting with the more elementary ones, and then finishing off with the more advanced ones, okay? The more advanced ones take longer, and to be honest, as I'm going to explain to you later, I don't expect most students to get the advanced questions. The exam is designed that way. The exam is designed so most students won't finish it. I mean, you won't be able to get a perfect mark in it, of course. If most of the students got 100% of the exam, it would be a pretty silly exam. So there's not much point going to the hardest questions, because the very hardest questions in the exams are going to be ones that only a small handful of students get out completely. Just like the mid-semester exam. Okay, in the mid-semester exam, there were questions there which were only a handful of students got through. That's okay, all right? So don't feel bad if you're not getting through those ones, unless you're really hoping to get yourself a 95 in the course. It's going to be fine if you don't get through those. So I'm going to focus on the ones that are more core and more elementary, all right? Any questions or feedbacks there, Leo? Okay, I already see someone saying they'd love to have one-to-one consultations. Please keep them going. All right, message received. Very happy to do that, folks. Yep.
It's pretty quiet in the chat right now.
Pretty quiet in the chat. Okay. Now, and I see the message on Piazza about the one-to-one consultations. So please, folks, if you want one-to-one consultations, can you please go to the message on Piazza and upvote it? I just want to get a sense. So far, I've got 2 people, but 2 people out of 500 is not very many. I think the 2 people are probably right on the money, and I'm very keen to do it. But it would help me gain confidence that it's not just 2 people. If more people would upvote that by hitting the helpful button on those messages. So just to give me a sense, all right? Okay, because it's your tutor's time and everything, and it's a lot of times. It's 9 hours a week. All right. With that, I think it's time to start looking at the exam. All right. Now, what's the first thing you need to do? The first thing is to go to the practice exam. Let's just do it from here. Here we go. We're going to go to final exam. And remember, you need to check the university timetable to check the exam time. And also remember that the exam time is the same for everyone unless you've written to me on Piazza and asked for a different time, in which case I should have by the end of this week. The end of this week, I expect to tell you your exact time for those of you who are living. Most of you are in India, but for the people who are India and Pakistan and the Middle East, those people, I'll tell you your exact time soon. All right. And if you did not contact me and you did want to sit an exam at a different time, you need to contact me before Friday, because at that point it's going to be set in stone when that other time is, and I'm choosing the time based on all the feedback I've got from the students who have contacted me so far. So if you haven't contacted me, look on Piazza. You'll see there's a notice there about final exam and time zones. And if you have not responded to that, you should, and make sure you follow the instructions exactly. It tells you exactly what I need to know, and please do that. All right, so preparing for the exam, what you need to do beforehand, ensure that you've got a working home setup. This is incredibly important, folks. We do a technical test like we did with the mid-semester exam. The purpose of the technical test is to make sure your home setup is working. All right, this is so important. The last thing you want is to get into the exam and then realize you didn't have IntelliJ working properly or something like that. We're going to have tutors on hand to help you, but you know, you're going to blow your exam time. You just don't want to be there, right? So the way we address that is by having the technical practice before the exam. We'll do 2 of them each 12 hours before the exam. That's my current plan. And the idea is you go and do a very simple version of the exam, which just has a hello world and a very basic multiple choice question. And you test that out. You send it, you commit it, you push it, you check the CIs, make sure the CI is happy with what you've done. And at that point, you'll know that you've got the basics working. You can compile, you can make programs run, you can make them go to the CI and so forth. And at that point, you're done and you're ready to sit the major exam. And when you do that, all you have to do is an upstream, not upstream, but all you have to do is a pull. You just do a pull and you'll get your exam in your repo. Okay, so your repo starts out empty except for the practice questions, and then you do a pull when I tell you to on the day of the exam, and you'll get your details. At this stage, what I'm trying to do is get the exam set up with a Zoom webcast because we could not do it properly in the mid-semester exam. We maxed out the number of users, unfortunately, and that was something I hadn't anticipated. So I am anticipating it this time, so I'll try and get that organized, but it'll basically be the same deal. That is, I'll send messages and stuff via a PowerPoint and a Zoom, and yeah, that's how we're going to work. I suppose the other possibility is I could do it via live stream. That's another possibility. I could live stream it via YouTube, but if you don't have access to YouTube, then that won't work. All right. So technical check and so forth, and what you need to do during the exam. Now, in here, it tells you about the practice exam. That's what I want to focus on today. Okay, so here it tells you to familiarize yourself with the practice exam. So let's go there. We're going to the practice exam now, and this is what you're going to see. Notice this one here. Here it sits in the COMP1110 repo, extra COMP1110 exam. You need to go and fork this. It looks like only 80 students have forked it. You all need to start forking this soon. Otherwise, you won't be able to do the practice exam. So fork this and make your own copy. All right. Now, when you get an exam like this, you'll see all this stuff here, and then you'll have a README file. Make sure you've read this, and most of the README file, or a lot of the README file, you'll get in the practice exam. All this stuff here will come in the practice exam. And then down here, there's a bunch of actual questions. Okay, these actual questions will get populated when you do the pull at the start of the real exam. Okay, and what you need to know is there's a few things you need to know in terms of doing this. First of all, this practice exam I've given here is the real exam from last year, this time last year. And notice, you think, oh my God, there's so many questions, right? Question 1A, 1B, 1C, and so forth. No, you only need to do one of those. The point is we have randomized exams and their variations. And these are all very similar, but slightly different. So you just need to choose one of these. And I'm going to do some of these. Probably not question 1.1 because no one asked me about it, but I'll be doing some of the questions and I'll just be choosing one example. What I highly recommend you do is to save some of these practice questions in reserve for closer to the exam and practice on ones that on some of them. So maybe take this one here, or 1.1a, try and do this, find out what you can't work out, go to the one-on-one consultations or Piazza if you can't figure it out. And then once you've totally nailed it, then move on to 1.1b, which you'll find is quite similar, but a little different, and make sure you can do that fluently and so forth, and do that. And you've got all these practices, okay? So these are lots of ways you can practice. And again here, 1.2a, 1.2b, that letter at the end, the ABC, in the actual exam, you won't have that. You'll just have question 1.2 and you'll only get one variation. The A, B, C, D are just the 4 variations that different students will randomly get assigned. Okay, so you just see these as examples. I'm just giving you lots and lots of opportunities here. 1.3, and question 2, same deal, and so forth. Notice that when you get down little ways here, you'll get to, question 6 is multiple choice. For the multiple choice, you need to put your answers inside a CSV file, which is in the repo, and you need to put them in this format. If you don't put them in this format, the CI will throw them away, okay? You need to put them in this format, otherwise you won't get marked. The CI won't tell you whether your answers are correct, because if you think about it, if the CI told you whether your true-false questions were correct, remember the thing about error correcting codes, if it told you what was correct, then obviously you could flip it and make it, if it was wrong, you could flip it and make it correct. So it's not going to tell you what's correct, but the CI will tell you if it's in the right format. So if you send something that's just rubbish to the CI will say, no, I can't read your CSV file, and you need to format it correctly. We have an example in the practice exam, right down the bottom here. Where is it? Down the bottom, there. So very, very, very silly multiple choice questions. Identify which of the following colors best represents the color of the sky. Okay, so the answer is blue. And so you want to write in 1, A for that example, all right? And then for maths, you got to say what's the addition, 2 plus 2, and you're going to say B. And, well, we got it wrong here. But you got to put down the answers to the questions. And if you've got a question you don't have an answer to, like question 3 is unanswered here, you leave that out altogether. So there's no line for 3 because this person didn't answer 3. All right. So you should make sure you understand how to do that. Again, it'd be pretty silly to lose marks on the exam simply because you didn't follow the instructions on how to fill out the multiple choice. It's actually really simple. You just need to write it out like that. If you don't do that, you will lose marks. You could lose the entire question, which is pretty ridiculous, just because you don't follow instructions. Okay, so make sure you follow instructions. The instructions are really clear, and you've been given examples. You've been given examples ahead of time. All right, so make sure you do that. Right, I think that's the overview of how the exam works. The actual mechanics are really just like what you saw in the mid-semester exam. You know, you get you'll open it in IntelliJ. Here, let's go to IntelliJ. Here it is. Okay, here it is in IntelliJ, and of course there's tons of questions here, and that's because we've got the practice exam. So you won't see anywhere near as many questions in the actual real exam because this has got all the repeated questions in it. And if you go here, you'll find all the different questions here, and you'll see here there are multiple 1.1s. You don't actually get one of the 1.1s. There's multiple 1.2s. You don't get one of the 1.2s, and so forth. Now, one of the really important points to notice is that the questions are not of equal difficulty. And even more, look here, part 1, part 2, different parts of questions can be harder. Okay, so you need to use your time strategically. Okay, use your time strategically, which means that if make sure you do the parts that are easy first. Okay, don't embark on the most ambitious and difficult question at the start. All right, that's really bad use of your time. So start off with things like the 1.1 questions, not Bishop, that's not 1.1, it's actually 1.3. Oops, hang on, oops. Accidentally turned my do not notify on permanently. That's not what I wanted to do. All right, so you do one of these ones here, one of these 1.1 ones. Make sure you've got one of those working, then move on to 1.2. Probably skip 1.3 altogether. 1.3s are quite hard, okay? They're ones that could take, if you got stuck, you could spend an hour on that, which would blow a huge chunk of your exam. And look how many marks they're worth. It says it right here. It's worth 5 marks, okay? It says it in the README. You go to the README, it tells you how much it is. A bit slow. Come on, there it is. Okay, it tells you here how much they are. Make sure you budget your time. The exam should be worth 100 marks. Last year it was worth 90, but it should be 100. And you need to budget your time appropriately. This whole of question 1 is worth 15. If I were you, unless you're really ambitious, I'd be going for the 5 marks for 1.1, the 5 marks for 1.2. Then I'd be moving on to question 2. All right, now, one thing I'm promising you, one thing you should all feel good about, is that the exam you will sit will be very similar in style to the previous exams. Okay, so when you sit down in front of the exam, everything should feel familiar to you. The structure of the exam should be familiar. The way we do it in IntelliJ should be familiar. All these things should be familiar and unthreatening to you if you've practiced, okay? Because it's all been made available to you in advance. So all that stuff will be similar, okay? The only thing that's going to be different is, of course, the actual questions will have different questions in them. All right? So at this point, I think I've covered everything I wanted to say in terms of the broad overview of what the exam's about and how you should do it, and giving you the point about strategy. Okay? I want to emphasize this thing here. The exam will be auto-graded. Okay? It is important your code pass the tests. right? If you push work, which doesn't pass the CI, you're gonna fail, right? You're going to fail that test, right? So what you do not want to do is to push things that kill all of the results, right? So if you, for example, if you enter a code that has compiler errors in it, then it's not going to pass CI because you can't even run the test. If I write code right here in IntelliJ which has compiler errors and I try and run the test, it won't let me run the tests. So do not send that to the CI, because if you send that to the CI, then you're going to get 0 for the exam, right? Because none of the code will compile. Okay, you do not want to do that, right? That'd be a very bad mistake, right? So you always want to make sure that what you send to whenever you commit and push, the code is actually working, right? And do it as regularly as you feel comfortable. I would definitely recommend doing it after each question. As soon as you've got a question working, you run that test, you see you've got the result you wanted, push it away. If you get stuck and you think this is hard, I've got 3 marks out of 5, at that point, again, I would suggest you commit and push it out of the way and come back and try and do the other bits later. All right? But don't send code, don't upload code that has syntax errors, because that won't even compile. That's a really bad idea. All right? Now, Leo, are there any questions there in that chat?
Not really. It's really weird because I think today's chat is really quiet.
Okay, the chat's really quiet today. So folks, this is a revision exam, so it's really driven by you. If you don't have any questions, then there'll be less to do, but I'm going to forge ahead with the questions on Piazza right here. The first one I'm going to do is, I think, let me see, I've got some notes here. Hang on, what's happened here? Yeah, maybe the first one I should do would be to quickly look at question 3. Someone asked on the chat, someone asked on the chat here, what did they say? So there's a whole bunch of questions. Some of the questions here are about the hardest questions, so I want to do them last because otherwise it's not helpful. Someone said the last 2 methods of Hollywood and library making use of max. I'm going to very quickly look at question 3. Why am I looking at question 3? Well, because it's right in the middle of it's one of the Piazza questions. From Sinha, and it's some of the core content in the course. So let's have a quick look here. Let's go to library, okay? Let's have a quick look at what this question's about. And I'm not going to try and do the whole question here, even though it actually won't take that long to do. I'm not going to try and do it all here because it will take too long, because it's, how much is it? It's 25% of the exam or something. What was it? Let's go back here. Yeah, it's 25% of the exam, right? This should not be a hard question, folks. I really strongly encourage you to go and do this Q3 library and the Q3 Hollywood. Okay? Do these 2. Make sure you know how to do them. What this is about, this question, is about using containers. Okay? Using containers. So what you need to do is think, okay, I've got a question here, and it's supposed to be about a library full of books. Each book has these things in it. An ISBN, which is something, it's an identifier for the book, a year number, a list of authors, a title, and a rating, okay? Now what you need to think about is how you're going to represent the library, okay? And you need to think about what questions you're going to be asked, okay? So you're going to add a book here. That's one of the first things is you have to add a book. To add the book, you need to have, presumably you're going to have an object, a book object, right? Presumably, okay? And so to do that, you want to make an inner class, presumably, for your book, okay? You don't need to do it this way, but that would be the way I'd be approaching it. You'd be making an inner class for a book, which allowed you to represent those different aspects of a book. Not too hard, right? But you need to do something with the book, okay? What do you need to do with the book? You need to put it in your library. How are you going to represent the library? Well, probably you could do it as a set, maybe, but probably a better idea would be to use a map, just like we did with our class list in class. We had all the student IDs, then all of the student objects. Okay, we had student IDs as the keys in the map, and the values in the map were the student objects. Remember that? We had COMP1110 students, and we had them indexed by the student ID. Same thing here. Notice the ISBN in this particular example here is a unique identifier. Okay, unique identifier. That sounds a lot like your UID for uni, right? So probably a key ID there. Maybe that's going to be the way to index your library. You index it on ISBN, but you may need to do other things as well. So this seems Note, where it says unique identifier, that's a very important idea when you're talking about sets and maps, remember, because the set of keys has to be unique, all right? So when someone says to you in an exam question, this thing's a unique identifier, your eyes should light up and think, maybe that's the way I'm going to structure this thing. When you delete a book, how do you delete a book? Well, let's assume you have built yourself a map. So what's deleting the book going to be? You're just going to be removing it from that map. You may have multiple maps. It depends on the question. You may have multiple maps, and maybe you don't have maps. Maybe you've got lists or sets or something. But you're going to have some data structures like that, probably something like a map. And if you delete the book and you've got multiple maps because you've got something complicated going on, you'd better make sure that the book is removed from everything, okay? But if it's just one map, then it becomes easy. Just delete it from that map, okay? So, and again, you've got the ISBN. Notice that the ISBN here is represented as an int, not a string, okay? So it's not a string. Here it's an int. Notice the year is an int also, okay? Notice also that the authors are a set of strings. That gives you a lot of clues as to how you might make this book class. So I wouldn't go too far and implement this book class until you've looked at the questions here. The authors are not just a pile of strings, it's a set of strings. The title is a string, a single string. And the rating, this rating up here, is actually represented as a float. So probably when you make your book class, you want to reflect all those things in there. Now let's go down to book count. Okay, book count's going to be easy. If you had a map and your map's always up to date, then the book count would just say how many things are in my map. Okay, because that tells you how many are in the library, right? So it's easy. Get the top books. Okay, so here what you want to do is to look at the titles of all the books that have a rating higher than or equal to the rating provided. So how would you solve this? Many ways to solve many of these problems, which is why I'm always reluctant to give you a formulaic answer, because there's lots of answers to these questions. And this is why I strongly encourage you to do this. By the way, folks, you're warmly welcome to put this stuff on Piazza, to ask questions on Piazza and discuss it on Piazza. Okay, this is not, the practice exam is not confidential, it's not private, you're allowed to discuss it on Piazza, and it's not assessable. Obviously, the practice exam is not assessable, it's not an assessment item. So if it's not an assessment item, you can discuss it on Piazza. So if you want to ask a question about how to do this, go feel free and ask on Piazza. Also, feel free to ask your friends. You're highly encouraged to look at things like the practice exam in study groups and ask your friends, how would you solve this problem, okay? Now, get top books. A very simple way to get top books, I'm not recommending this necessarily, would be, what does it ask you to do? It asks you to return a set of strings with all the titles. So one way to do that would be to go through the map of all the books, and for every book whose rating was higher than this, you just add it to your set, or add the title to your set. So it's a set of strings. So it's a for loop. It goes through every single book in the whole library and just looks for it. That's, in terms of complexity, we call that order n, because it's got to walk through every single book in the library. That's probably just fine, right? You can do fancier things like have fancy data structures that told you where the top books were, but for this is probably just absolutely fine, all right? Get author books. Get the names of all the books that were written by a particular person. A little bit similar to this. You've got to go through the books and find out all the books that had this author in there. So this time though, instead of finding out if the book has a rating higher than this, you've got to find if this book's set of authors include that specific author. Okay, so you're going to go through and look, see if this string is in the set of authors for this particular book, all right? Get the number of authors. Well, that's pretty easy. So here you're going to find out how many authors are in the entire library. That's interesting. So one way to do that, of course, a very simple way to do this, I'm not recommending this at all because there may be a more nuanced way of doing it, is to simply go and add all of the authors into a giant set and say how big's the set. Okay, because sets are unique, so there's no repeats in there, just put them all into a set, okay? But maybe the next question gives you a clue as to a slightly more important one, okay? Are these people co-authors? Now, how can you find out if they're co-authors? Well, one simple way to do it would be to go through every book in the library and say, is this person and this person both in the set of authors for that particular book, and go through to the next book. That's a perfectly sound way to do it. All right, but there may be better ways to do it. There are maybe other ways to do it, but that's a perfectly sound way to do it. So are they co-authors? That means, in principle, what it means is look at every book in the library and say, are these two people both authors of this book? All right. Get first published year. Now, here you've got to find out the year in which the given author published a book that is in the library, or -1. Again, a very simple way to do this, but not necessarily the recommended way to do this, would be to go through every book in the library, find out if this person was an author, and if they were, see what the year of publication was, and see if it is earlier than what you've got so far, and -1 if there's nothing there. Okay, and then get max books. This is actually the question the person asked. Okay, so someone asked this. Sania, I think it was, asked this question. Yeah. All right. So their question was, this question asks you to get the greatest number of books that any person has been an author of. Oh my goodness. Okay. So this asks you to find out the greatest number of books that any person has been author of. Now, one way to do this would be to say, for every author, have a map which goes from author to number of books, right? So you go through the whole library and make a map and say, okay, this author was in this book, and for every author in the book, you add to their count. That's one way to do it. Another way to do it would be to have perhaps a better way, perhaps not. Another way to do it would be to say that when you add a book, you actually maintain not just one big map of all of the books in the library, but another map of all the authors, and the author map might have a mapping from the author name, like Suzanne Collins here, to the list of all the books that author has written. Then that may answering these ones a little bit easier, right? So now you just go to the entry in that, so it'll be a map from author name to a set of books, okay, probably a set of ISBNs. Then all you do is look up that, find out the set of ISBNs, and then look at each of those things and find out which one is the oldest of the books. And likewise, when you come here, all you need to do is go through this this map of authors to books they've written, and go through the entire map and look for each one of these and find out which one has the most books written. Okay? And then here, this gets the maximum number of unique co-authors of any author. Okay? So this says, so for any author, how many different co-authors do they have across all the stuff they've done? All right, so this is what this means is you need to go and look. So the simple way to do this, not necessarily a good way to do this, would be to look through the entire library and construct a map for every author with a set of their co-authors. So as you got to each book, you create an entry in the set for each author if there wasn't already one there, and add all the other people into the set of co-authors. Okay, it's a set. You do this through the whole library and you end up with a giant map which maps from author to set of co-authors. And it says unique co-authors. Well, sets are unique. Okay, so it won't have any repeats in there. So if someone's written 2 books with William Shakespeare, well, it won't show up twice. All right, so so what you need to do is there's many ways to do it, but one way to do it is to do that. Now you've got a map of sets, and then all you have to do is go through that map and find out which entry in that map has the biggest set. And the one with the biggest set is the one that gets the size of that set is the maximum number of unique co-authors. All right, I think I've answered that question. I hope I've answered that question satisfactorily. Leo, are there any questions there?
Yes.
Just before Leo asks the question, let me also say, in a minute, I'm going to get to coding. Some of you probably think, oh, isn't he going to write some code? Yeah, I'll write some code. I'll try and answer some of these questions with code. I didn't want to do that for the question we just did because there's a lot of stuff in there and I really want to cover it at a higher level at this point. But I'm going to go through some code in a minute. Yep, sorry, Leo, go ahead.
Benjamin asked, how do we implement a map in Java?
Well, for this question, there's nothing here about you asking you to write a map in Java, right? So you can implement a map in Java just by creating a hash map or or some other kind of map. Okay, we covered this in I don't remember which unit it was in, collections, which is one of our. Let me go here and let's find out where we cover it. But COMP1110. Nope, that's not where we want to go. So COMP1110, sorry, I thought I would have had that tab open. There it is. And we go to the lectures and go to Java. I think that's where we covered the collections. Right down the bottom here somewhere. There it is. So J14. Okay. So if you go to J14, you'll see a covering there of, hopefully this won't kill my live stream. Downloading this file here. There you are, collections framework, interfaces, basic operators, collection types, maps, all right? So I don't know quite what the question was, but if you're not sure how to use Java's collection types, I strongly suggest you go and look at J14. Leo, was there any other questions there?
There are actually two. So Hoy asked, I face some challenges with problem-solving skills. For example, the Bishop question in 2020 exam, it takes me a lot of time and skill. I'm not sure if I have figured out the good algorithm for it. Can you please advise what would be a good strategy to prepare for it?
Which algorithm's that? Which question?
The question, the Bishop.
Oh, Bishop. Yep. I'll take a look at Bishop at the end of this class. Someone else asked about that, so I'm going to do Bishop later. I'm not sure we'll have time to go through the whole thing, but Sina asked about that. I didn't want to do that first because it's a hard one, right? That's a hard question. That's a great question, whoever asked that question, but that's hard, right? So that's the sort of question, you want to nail that sort of question if you're expecting to get a mark in around 90 or so, okay? If you're not nailing it, don't panic, okay? Because that's the sort of question, that's going to be the last 5% in your exam. That's one of the hardest parts of the exam. So don't be stressed if you're not figuring out questions like Bishop. Notice Bishop is a question 1.3. It's not a 1.2, it's 1.3. There, it says 1.3. Bishop, number and word. They're all hard questions, okay? They're hard questions. So I will take a look at them and I'll try and give you an overview to try and answer that question that I just got there about how to strategize around answering a question like that. Any other questions there?
Dahao asked, in the final exam, Javafx part, for the Javafx part, will it be multiple choices or we need to write the program?
Yeah, it's not going to be a program for a simple reason. The question there was about Javafx. For Javafx, it's hard to do unit testing with Javafx, so we're not going to be auto-grading Javafx, okay? So which, by implication, means that Javafx, if it's in the exam, will be asked in the form of multiple choice, right? If it's in the exam. And you can see that, there's an example of that. Go to the README file, you'll see there's an example of Javafx in the README. One of the questions in the sample exams is Javafx somewhere. Grammars, complexity, Javafx. So there's some questions there. Okay, that's the kind of question, I'll put it on the screen there. That's the kind of question you should expect to get on Javafx. That's the style of question, all right, and the level of difficulty. Okay, multiple choice doesn't mean easy, by the way, folks. You have to figure things out to solve problems, to answer multiple choice questions. But you won't be writing code, you'll be reading code and understanding what it means. Okay? So hopefully that answers that question. Any other questions there, Leo?
There's a question asking, can you give us a suggestion about the questions we should attempt first after Q1.1 and Q1.2?
So the question that the person asked is, which questions should you do first? The answer to that really depends on you. Okay? The strategy I would recommend is definitely 100% make sure you've done examples of all the questions before the final exams. You've practiced with a practice exam. If you've practiced with a practice exam and you know roughly how long it takes you to do these questions, just roughly, which ones you can do fairly quickly, which ones you can get most of the marks out for, then you should be able to strategize and say, hey, you know what? In the practice, I was able to nail those question 4s and they're worth 20 marks. Or I was able to absolutely nail question 3 and it only took me around 30 minutes to do question 3, and yet it's worth a quarter of the exam. So I'm going to do that one first, right? That's the sort of logic that should be going on in your head. It's a matter of using your time really effectively. I strongly recommend you manage your time and you budget time and say, okay, question 3, I'm going to keep the mark distributions the same, or at least I'll tell you if I don't, but my plan is to keep them the same. I expect to have a question, I expect to have 100 marks in there, so if I change it, I'll tell you how I've changed it. The point of me telling you that is, it means that you can go to the exam with confidence about how the marks will be distributed. Okay, so you should go into the exam expecting 100 marks. Last year's exam only had 90. You should expect 100. Okay, and use your time accordingly. All right, use your time accordingly. Now, if it were 90 marks, then the math there becomes easy, right? Because 90 minutes, 2 times 90 minutes is your 3 hours. Well, it's a bit more than that you've got. But you can do the maths yourself, okay? Work out how many minutes per mark, and then basically set a budget. So the question the person asked was which questions to do first. And my answer to that is do it according to what you feel comfortable with, and do it with good awareness that some questions are much harder than others. So don't spend time on questions that are really hard. Okay? And it makes an awful lot of sense to be strategic and spend 5 minutes out. You got 3 hours and 15 minutes. Budget 5 minutes at the beginning to go over the whole exam and make sure you understand how it all works out, where the easy bits in your view are and where the hard bits are in your view. And the reason why I've given this long answer to the person's question is because notions of easy and hard differ from every person, right? What you find easy or what you find hard is not what the person next to you necessarily finds easy and hard. So I want you to try and do the things that are most efficient for you. All right. Any other questions there, Leo?
Yeah, I think that's everything.
Okay. Well, let's get writing some code, folks, and let's do this question. Question 5. I got questions about question 5 on Piazza, so I'm going to do this. And this one here I can code. It's not too hard to code. What I want you to do, if you're online and you're watching live, I super strongly encourage you to look at question 5 and make suggestions in the chat if you have them. I'm going to blast ahead and code anyway. I'm reluctant to give you too many answers. Not because I don't want to give you answers, but because I don't want to make you only think in a single way. So I'm not going to do actor and address. I'll let you think about doing address yourself. I don't want to spoil it by providing, standard answers. Okay, there are many ways to solve these problems. Okay, first question is, so this one here is, there's a class here that represents an actor. So you've got, this person has got a given name, a family name, and a date of birth. They're all strings. Notice that they're all strings in this particular example. All right. So they've got this person, Kate Blanchett, and then there's the date of birth, right? Kate's date of birth. So that's the name of an actor. That's their first name. That's a given name. That's a family name. That's the date of birth. And we now need to do a couple of things for it. So this code here is already written for you. Then there's a fix me here. It says complete this, and a fix me here that completes this. This one here says return a hash code value for this actor. In implementing this method, you may not use hash code. The CI will check. So if you do this, you'll just sort of fail. All right. And remember also that if you do anything that subverts, or you try to subvert the exam, that's academic misconduct. So do not do that. Okay. So do not try and reverse engineer tests. Do not try and do tricks like, oh, I'm going to find a sneaky way to put hash code in here and no one will notice. If someone does notice, and I will, right? If that does happen, then you may be on an academic misconduct charge, which is really not good. Okay, that can be failing the course if you're cheating the exam. So don't do that. All right. So do this sensibly. Use your brains. Don't be silly. Okay. Now what we're going to do here is we're going to say do a hash code. What does it say? Implement this method. You may not use. Okay. So for this sort of stuff, we already explained previously that one great way to get a hash code for this is to use Java's hash code. But this question here says, no, we actually want you to think about making your own hash. Fair enough. Okay, so in this case, we're not going to use Java lang hash code, which is often a great way to do it. Here, they want us to do it ourselves. So what I'm going to suggest is we're going to make a hash by somehow or other mashing up these letters here. And if you're at the lecture on hashing, we did it with people's family names. I don't know if you remember that, but we did it with family names. And if you remember, what we did is we added up the letters and the people's names. We can do the same thing by adding together the given name, the family name, and the date of birth, adding up all those letters and making an integer, just treating the letters as if they're numbers, right? We can do that. And that will give us just a number which reflects the given name, the family name, the date of birth. What's important is if someone comes back to us with the same actor, Kate Blanchett, and that exact date, we get exactly the same number back. So it's going to be deterministic, all right? And it can't take too long, okay? Also, we can't just reply 0. Let's just try that to start with. Let's just answer 0, and you'll see what happens here. I'll return something. This is a really bad hash code. It's just to return the same thing for everyone. We do not want to do that, okay? But let's just do that to see what happens, right? Incidentally, the other thing you all need to do is work out when there are tests here that you can answer really easily. Like maybe if we say return 1, we actually get 1 mark for this. If you get 1 mark, then great, commit it and go if you can't think of anything better, okay? Because 1 mark is a lot better than 0 marks. Okay, I don't think we're going to get 1 mark for this, but who knows, we might. Well, let's have a look here. A little bit slow. We've only implemented the hash code. The hash code deterministic. Well, it is deterministic, but it's failing that test. Okay, so it's failing all the tests here, which is not very surprising because it's a terrible, terrible hash code. But now let's do something simple. Let's add up the fields in int family, int H, we'll call H, it's going to be our hash code. And then we'll do a for loop and we'll go through all the characters in their given name and return that, okay? Add up them, treat them each one as a value and add them up and return that. We've done this before and we did this in the hashing lecture. If you go back to the hashing lecture, you'll see how it was a suggestion someone on the chat had. And so I'm just going to do the suggestion from the class, from that lecture. And Leo, please interrupt me if you get suggestions from people. I is less than what, given a given name, right? Dot length, length. There it is. And we can't say given name dot hash code because that's gonna cause us to fail the test. So don't do that. Okay, we could have done it here, but it would fail the CI. They told us not to. Okay, otherwise that might have been a good way to do it. Now we say I plus plus, and then what we're gonna do is we're gonna say H equals H plus, or we can say H plus equals if you want to be a little bit more concise, and then we'll say given dot charat the index I. Okay, like that. And we just what's happened here? What's the problem? Oh, it may not have been initialized. Yeah, we've got to initialize this to 0. Thank you, IntelliJ. All right. Remember, IntelliJ is going to help you in the exam. It's your buddy. All right. So now, unless it does something really strange, but do utilize it when you can. So now we've just done this here. Let's have a go. Remember, we haven't started answering the equals question, so we're definitely going to fail at least two of the tests here because we haven't even tried to do the second part, which is the equals. But let's just see how we go on the hashes. Okay, so great. We've got a deterministic hash code, which means that we always get the same answer. It's uniform, but it's not uniform enough. We passed A, but we didn't pass B. Okay, so this is not perfect. Okay, so our hash is not good enough. So then what we can do, but if that's all we could think of, at least we've got 2 marks instead of 0. So let's commit this and push it, right? That's what I would suggest you do in the exam. But what we can do is we can just copy this code over and do the same thing for their family name and the date of birth. So let's just do that. Family, family, date of birth, and let's see if that helps. Okay, so all we're doing now is we're just adding more stuff to H. So H is getting more and more rich because it's getting more and more information, if you like, out of this actor by getting all the characters make up each of their names and the date of birth. You can imagine that this is not going to be very good if the actors have got really short first names. It's not going to be very differentiating people very much. So here we go. Let's just run this and see how we go. Fantastic. We've passed 4 out of 5 tests, which is all we needed from the hash code. And we've got one last thing here, which is the equals. So let's do equals. Okay, so we've got 4 out of 5 now. Okay, so that was a great solution. Now for equals, what we need to do is, first of all, we need to compare all the fields. It says return true if this equals equal to the other one. The first thing to notice though is that the type here is not actor, it's object. Okay, so if the thing that we get given isn't an actor, then are they equal? Definitely not. If the thing that we get given is null, are they equal? Definitely not, because you can't call equals. Our actor mustn't be null, because if it were, you wouldn't be calling equals on it. So let's just get rid of those cases first. So we'll say if object equals null, then or how do we find out if object is an actor or not? Can you remember how to do that? There's a special operator in Java to do that. Can anyone remember? Let's do this. We'll say object. What we use is the instance of operator. The instance of. Object is not an instance of Q, what is it, Q5 actor. There it is. Okay, so if either of those are true, then they're definitely not equal. So return false. Okay, now, oops, return false. Okay, so return false. Now, at this point, we know that the other thing is an actor, and we just need to see if it's the same actor. So let's make a new variable just to be clear about it. We'll say Q actor A, and we'll say it's equal to we'll call it other. I like using the word other when we're comparing two things like that. Object. Okay, so all I've done there is just said, let's just rename it. Now we know for sure it's an actor. We've given it the right type, and we've called it other. We'll just make the code that follows a little bit cleaner and nicer. Okay, so now what we're going to say is that we only want to return true if all the fields are the same. So they're going to have the same family name, the same given name, and the same date of birth. So we can just do this. I'll show you, like we'll do a first stab at it. I'm going to intentionally make a mistake here. And if someone in the chat's got a better suggestion, go ahead. Because what I know what I'm doing here is not ideal. Return given dot equals other dot given, right? And family, dot equals other dot family, and date of birth means this object's date of birth equals a string equality. So I'm using that dot equals method, equals other dot date of birth. So we're saying that you've got to have the same given name, the same family name, and the same date of birth. All right? Oops. Oh, I just didn't close the parentheses there. Okay, that's better.
We got a suggestion from Jose.
Yep. Hang on, just one second. Just 1 second. Let me run this. And now, yeah, okay. Now let's go ahead, Leo. What's the suggestion?
Suggest we can just use a hash code function.
Okay, interesting suggestion. We could use a hash code function. That's a great suggestion, actually. But very good idea, okay? But that's only true. So the suggestion from the class was, let's use the hash code function. That actually is correct in this particular case. Why is it correct? Because here, no, it isn't correct. It is not correct, okay? So sorry, not correct. The reason why it's not correct is because, think about this. If we had two actors, one was called Kate, and the other one was called, I don't know. That's a name, okay? Imagine this actor is, well, called this. Well, actually call him that. Call him Keta, okay? All right, we've got two actors. One's called Kate, one's called Keta. And they're both called Blanchette, and they're both the same date of birth. All right? If you did that, they'd have the same hash code, but they'd be different people. Okay? This is a very good example of why you can't hash codes. The fact that two hash codes are equal does not mean the things from which the hash codes came are equal, because this would provide exactly the same hash code as the other one. If you look at how we wrote our hash code function. Okay, we said add up all these letters. If you add up those letters, they're going to be exactly the same because they both have a capital C, both have an A, both have a T, both have an E. All right? That's not going to work. So we won't do that. It's a great idea though. Very good thinking. Hopefully you understand why it's not going to work though. So instead what we can do, what I wanted to show you is while the person was asking the question, we ran into a problem because one of the examples had a null family name. Okay, if you had a null so the code I wrote was wrong, and I knew it was wrong when I was writing. I was hoping someone would see what was wrong here. And this means we can either check to see if either we or the other one has a null given name, a null family name, or a null date of birth, or we can be a little bit smarter and use the code that someone suggested in the lecture just not long ago and wrote it on Piazza. I can remember someone did this. There's a special method here, which is this is just a nice little trick. There's a method in objects called equals. Okay, and now what we can do is we can say, we can ask if given and other.given are equal. Okay, and what that method does is it will check that they're all the same. All right, and we can do the same for for family and for date of birth. So let's just do that. Okay, this will actually do the check to make sure that the given name's the same, the family name's the same, and the other is the same. There's a problem with this though, I suppose, because the test may disallow you from doing this. But anyway, we'll family.given. Oops, date of birth I meant to say. We run this. Just looking at the time here. How are we going? We're going okay. What have we got here? Is it going to let us do this? Yeah. Okay, so now we've tested. And the key thing there was we need to test for null as well as testing that the fields are the same. All right. Having done that, what was I going to do next? I had in mind to do... Oh, someone wanted to do caps. This is a little bit more interesting, a little bit more tricky. So the question's now getting harder. Was there any other thing from the chat? Anyone want me to go through any other questions or say anything more about the stuff I've done so far?
We have an interesting question from Benjamin. Benjamin asks, how is objects.equals different to just equals, just the object.equals?
Because the question was, what's the difference between objects.equals and object.equals? Object.equal is a method in Java lang object, and that's what I'm using here, okay? Oops, that's what I'm using here. So in this case, let's look at this code here. This is using, okay, let me write some comments here to make it more clear. So this is using objects.equals, and the line above is actually using object.equals. So I'll write the code there. Okay, that's what that is there. That's the object.equals. The thing with object.equals is it's an instance method. We've got to call it on given. Okay, so we call object.equals on given. Look, another way to write this code, let me write this more verbosely. And the problem with this one, when I ran it, if you remember, is it failed because one of these fields was null. Okay, so one way to do this, to write this more correctly without using objects.equal is the following, which may be what I should have done in the first place, to make it really clear. It's not as succinct, but it's very clear what's going on here. Oh. There you go. Why is that red? Oh, sorry, I'm just not thinking. Okay, there we go. So now what that does, if they were both null, then they would be equal according to the double equal sign if these two are both null. And so this code here would not ever get checked. If they were not equal, so writing this properly is a little bit tricky, because what you have to do is you have to check if one is null, then they both have to be null, okay? So if, okay, hang on, so say given equals null, if given is null, and other dot given equals null, then you're okay, all right? But you also need to, so it's one way in which they're equal, they're both null. But you only want to do this one here if given is not null, because if given is null, then this will fail, this equals will fail, because you'll be calling equals on a null. You can't do that. Or given not equal to null, and they're equal. All right, so that's now legitimate. All right, so either they're both null, or given's not null, and given's the same as other dot given. Okay, and you can just, now we can duplicate that code. You can see this is quite verbose, and this is what's so nice about this method here is it takes care of all that for you. So let's write this out 3 times in a row, put an and in front of them, like this, like that, and change this to family. So hopefully by writing it out longhand like this, you can see what's going on inside of that objects.other. Oh man, I'm typing this wrong. I think I've managed to do that without too many mistakes. All right. There's our second way of doing it, which should be correct unless I made a typo in there. That should also work. All right, and you can see that doing it this way is more concise. But if you look inside of this, it should be essentially the equivalent. Nope, what's happened here? What did I do wrong? They're not equal, but it says they're equal. Okay, that's because, that's interesting. Actors Michelle Williams and Robin Williams, they're exactly equal except their first name. See that? So why is this not working on given? It should fail because their given names are not the same. So given is equal to null and the other one's null. That's not true. Then it says given is not equal to null and given equals other dot given. Well, that should be testing for that. Why is that not working? Can anyone see what's wrong with this code? I've made a mistake here. Everything's in the example is exactly the same except the given name. But the code looks okay to me unless I'm misreading something. Nope, I can't see what's wrong here. I've made some mistake, but I can't see it. And anyone in the chat there can see what I've done wrong here?
I think students are asking you to double check the bracketing around.
Oh, yes, yes, very good. Yes, thank you. My parentheses are wrong. That's what it is. It's exactly what's wrong. Parentheses are wrong here, and that's partly just me not seeing it right. If I make it much more explicit here, this should fix it. My parentheses are wrong, and then I'm not doing the precedence correctly. It's best to make things really explicit, and I just got that wrong with my cut and paste. Okay, so now it should work. Okay. Thank you, folks. Good call from the students on the chat. All right. Unless there's any further questions on this, I'm going to jump onto caps now because we're running out of time, and I really wanted to do caps, and I also wanted to do at least make a start on bishops because people asked about that. Okay, so let's look at look at caps. Now, what's really important here, again, folks, in terms of being strategic, is notice it's got part 1 and part 2. Let's do part 1 first. That's really simple, I think. What they're asking us to do is basically just what we did in the lecture, the last lecture. We did this on Friday's lecture, okay? It's just sort of saying, open the file, and if the Boolean is false, simply copy all the bytes. Okay, so we're just going to do that part, and it's going to give us 2 marks, right? So let's just do the case when the Boolean is false, and we're just essentially going to ignore the Boolean. That's the Boolean there. It just says copy the file. So we're just going to say, okay, so let's just start off by completely ignoring the Boolean, all right? And then we should get those 2 marks because but we're going to fail on the next part. All right. So now what we're going to do is we're going to say in equals new file input stream input. Right. So this is going to open up that file. Right. And then IntelliJ is going to say, hey, don't you want to import it? Or no, surrounded by try and catch. Yep, we'll do that. Okay. So now we're doing that, and we also want to open the output file. Out equals new file output stream. There it is. Output. All right. So now we have, what's the issue here? Oh, yeah, I got the wrong type up here. Okay, so there should be an output stream. All right, there we are. Now what we're going to do is we're going to read all the things in the input stream byte by byte. It says they're bytes here. Just treat them as bytes. It's what it said. Blah, blah, blah. Read the bytes of the input file. Blah, blah, blah. So we're going to read these bytes in. Remember, we have to use an int to do that. So we're going to say int I equals 0. Start off like that. And we say while I is not equal to -1, do the following, and we're going to set yi equal to whatever gets read in from that file. I equals in.read, like that, okay? And then what's it complaining about now? Unhandled exception, that's fine. We're going to add that to the block. Add exception to, no, add catch clauses, yeah. Okay, so now we've got a catch clause for that. All right, so now we've dealt with that, and we're going to read this in. While it's not equal to -1, we're going to read through this whole thing here, and we're going to say out.write I. So we're going to output I, and then it's good to have a finally clause here to close things. Finally, in.close, out.close. Okay, and don't forget they can also throw exceptions, amusingly enough. Come on. There it is. We'll put the out clause in the same thing, seeing as it throws the same exception. Okay, there we are. And now we should find, I think, if I haven't made a mistake here, we're going to read all these things in as long as we don't get to the end of file and output them. All right? So let's do that. Oops, I ran the wrong test. I didn't pass everything. Don't worry, folks. Wasn't that easy. Run it again. Now, hopefully we've, yeah. Okay, so we've got 2 marks out of 5, which is what they promised us in the question. So now we've got to do this part, which is a lot more interesting, okay? And harder, okay? So remember to pace your time, folks. Pace your time. So here it says, open the specified input file. If the Boolean is true, then copy all the stuff, okay? Except any word of 20 characters or less that is immediately followed by an exclamation mark. Such words may be converted to all, should be converted to all caps before copied to the output file. Words longer than 20 characters are copied directly without capitalizing. Wow, okay? So what's interesting, they'll give examples. So if the input is high, then output is high. If the input is high followed by an exclamation mark, this is less than 20 characters, it's 2 characters, and it's followed by an exclamation mark, so we need to capitalize it. Here, we get this one here, high there. We only capitalize this part because there's a space here, which means that there weren't 20 alpha characters in a row. There's only this many alpha characters in a row because that's non-alpha. Okay, and same here. That there gets converted to this because this is a non-alpha, and we convert those ones, and foo doesn't get converted at all because there's no exclamation mark, and so forth. And if we have this giant word here, nothing happens because it's more than 20 characters. All right, hopefully you've understood the rules. We need to think about how to solve this. The part that makes this a little bit tricky is the fact that we don't know till we get the exclamation mark whether or not we want to capitalize it. That's the part that makes it tricky, okay? So what we really want to do, but luckily we know that the most amount of things we need to consider are 20. So what we really want to do is if we have something which we think could be one of these special words, then we keep putting it into a buffer. And then there are 2 possibilities. Either we'll find out that it's not a special word, either because it goes too big, like in this example, or because, or there's other reasons why it's not special. It's followed by a space, like is it like in this example here that gets followed by a space, not an exclamation mark. So again, there are lots of reasons in which we know that we're no longer in a word. Okay, so if we're in a word, we keep putting them in the buffer until the word ends. The word will end either with an exclamation mark or something else. Basically something that's not alphabetic, or if our buffer gets full. If any of those things happen, then we need to get rid of our word and we start all over again, okay? But if we do end the word correctly and it does finish with an exclamation mark, then we need to take all the stuff in the buffer, turn it into capitals, put it out, then output the exclamation mark. All right? So what I'm going to suggest we do is we start off with creating a buffer. We'll say we're just going to write 20 in there. It's disgusting, but that's what the question said, 20, so we're just going to hard code 20 in there. Now,
hi Steve.
Yep.
Michael asked a question. Why can't we just use a scanner here?
Why can't we use a scanner? We might be able to. That's a good question. Why don't we use a scanner? I haven't thought about that. I was thinking about this 100% in terms of the thing I just did on Friday. So I was prejudiced. That's an interesting question, Michael. If you think if you think we can do this with a scanner, which maybe we can, then you can just yeah, please go ahead and do that. That's cool if you can do it with a scanner. But I'm not sure that you can necessarily. Yeah, maybe you can. All right. Let's. Short answer: I don't know. And maybe and the reason why I'm doing it this way is because that was what was in my head when I started solving it. All right, so now we're going to go to, we're creating a little buffer. Either way, whichever, the interesting part of this problem doesn't really relate to the scanner, it really relates to the idea of having a buffer of stuff. And knowing that you need to decide whether or not this thing that you've already read in was a word. Okay, so you have to keep looking backwards. It's quite an interesting little problem. Okay, so what I'm going to do is I'm going to write a little tiny helper method. Is this a static method? It is. Okay, so I'm going to write a static method. Static Boolean. Actually, I don't need to do that. There's no need to do that. Let's not do that. Okay, what I'm going to do instead is when I read this letter in at the top here, I'm going to say Boolean alpha equals, I'm going to assign a Boolean determining on whether or not I is an alphanumeric character. Okay, so I'll say it's an alpha if it's going to be true if I is greater than or equal to A and less than or equal to Z, or, oops, and I is less than or equal to Z, or the capital version of that. All right. So if that's true, then we've got an alphabetical character, right? Right. And then the other thing I can do here is I can say Boolean exclamation mark I is equal to, if I is equal to this. All right. Now, the other thing I can do is create a new variable called index, IDX, set that to 0. And then what I can do is I can, if the, alpha is true and the index is some condition, and what we might do here, we've got to have some way of knowing whether or not we're still reading, we've flushed our buffer and we're at the end of a word, right? That's an interesting question. There are lots of ways of doing this. But we don't want to put it in the buffer if the buffer is full. That's the main thing, right? And index is less than 20. Then we just put this thing into the buffer, right? Buff IDX plus plus equals I byte. Okay, so if our buffer is empty and we're on an alpha character, then we, if it's not empty, if it's not full, then we keep going. All right, so we're making this thing up. Now, in any other case, then either the thing was not alphabetical, which means we want to reset things, or what's happened is the the index has gotten greater than 20. Now, if the index is greater than 20, we want to dump out what we just read, okay? Because it means that we've, like the supercalifragilistic example, that means we've got a non-word and we need to dump it out. But we don't want to reset the index. So we won't reset. The problem is that if we go above 20, we haven't left the word. We're still in a word, but we can't keep storing it because the buffer's only that big. So we want to dump the buffer out, and then from then on, we want to keep flushing stuff. So why don't we say this? Let's see if this works. We'll say if it's not alpha, then we need to dump everything out immediately. Okay, so if it is alpha, right, which means that we've got a buffer full of stuff, we need to dump it out immediately because otherwise we get everything out of order if we dump the buffer at the end and kept dumping stuff out. So we need to dump everything out. So let's just dump the buffer out here. We'll say for int I equals, what can I do I? No, j. Int j equals 0, j is less than buff.length, index j++, like that, okay? And then we'll just write it out. So we'll say out.write buff.j, right? So we're just going to dump everything out of that buffer. And we need to have some way of noticing that we've emptied the buffer out, emptied the thing out, and maybe we don't need to do anything else. Maybe that's it. Now, otherwise, if it's not alpha, we can set the index back to 0. Else, like that, okay? Because now we know that we've transitioned from being in a word to not being a word, which means we can set our index back to 0. So we're back at the point where we're ready to take in a word, okay? So if we come here again, and it is alphabetical, and the index is less than 20, which it will be if it's 0, then we're starting off a new word again, all right? Now, okay, we're done here. So this is the case that, too long. The next possibility is that we've got an exclamation mark, in which case we also need to dump that buffer out, okay? So if we've got ourselves an exclamation mark, we need to bump it out. I'm writing this in a longhand way. I'm just writing it as I think. We can make the code nicer in a minute. So now we'll say if we weren't still writing out letters, the only way we could got it here with the alpha is if our buffer overflowed, right? So that's what that case is. Otherwise, there's two cases. One is we've got an exclamation mark. The other is we've got something else. So let's just test the exclamation mark if the index is greater than 0. If we've got an exclamation mark and the index is greater than 0, then we need to if it's an exclamation mark and index is greater than 0 but less than or equal to, and index is less than or equal to 20, then less than 20, right? Then in that case, we have got ourselves a proper word we need to capitalize, okay? So we've got an exclamation mark, so now we need to go through all that stuff and capitalize it. So but only if caps is true. That's the other thing. So if the caps boolean at the top here is true, then we need to capitalize everything that we're going to output. So now we're going to say is byte B equals, now if caps is true, then we're going to do one thing. Otherwise, we'll just output buff J. Buff, we've got to give ourselves a for loop here. Copy that. Okay, copy that. Give ourselves a for loop, and depending on what's where the caps is set, we will okay, like that. All right. We're going to output B here, and B will either be buff J or the capitalized version of buff J. So if caps is set, then we need to capitalize buff J, which means that we need to change the letter from uppercase to lowercase. One way to do that is look at the difference between, I think it starts with, what does it actually start with? Capital A or lowercase a? I think it starts with capital A, and then you've got the lowercase a, so you need to take a subtraction of those. So you say if this is even more complicated. Maybe we just write an if statement here. Like that. And then we'll say if if caps, then if B B is less than capital Z, then less than or equal to capital Z, it means it was an uppercase letter, so we want to convert it to lowercase. No, we don't do anything, okay? So it means if it's greater than capital Z, it means it's a lowercase letter, which is where we do the conversion, okay? So now, if it's that, then we want to do the conversion, which means we need to add, need to subtract. So B equals, minus equals B, the difference between A and capital A. Right, that's the difference between upper and lowercase letters. There we go. Did I make, how many mistakes did I make there? Goodness, I don't know. We'll see in a minute. Now what we're going to do is, one other thing I forgot to do is we need to flush anything at the end here. If we get to the end of the whole thing, where's our while loop? So if we're done here, we need to then flush anything that's left in the, we need to do this, okay? If we run out of steam here, that is, we've read in the whole file, but there's still stuff in the buffer, then we've got to output whatever was left in the buffer. Okay, so we just go and do that. Now let's see if it works. It probably won't, because I undoubtedly made a mistake as I did that. So this is the harder part of the question. The first part we did in just a few moments. The second part was somewhat harder. Look, and I failed absolutely everything there. I even broke the other part. What have I done? All right, so let's just see what's going on here. Empty. Okay. Oh, it wasn't doing the spaces. What's going on there? So, oh, I know what's going on. I did all this stuff, but I didn't output the letter in the. Okay, so let's go here. Let me explain what I'm doing here. So we've read in a letter here, I, and then we've checked out a bunch of stuff. And if it was one we wanted to store, we put it in here. Otherwise, we did all this stuff here, but we didn't actually output I. Or did we? Sorry, I can barely see this. The screen's small. Where's this match up to? Else that. So we output I here. Okay, so I does get output there. All right. So I is being output. All right, let's look at this test. So we expected it to contain that, but we got that. So you expected to say hi exclamation mark, and it did hi exclamation mark. Oh, why is it coming out twice? My goodness, why did that happen? There must be something else here. It's outputting it twice. Where's this? Oh, I see. Because we're outputting it, we've got this statement here in the wrong place, okay? What was happening was we're outputting the letter, even if we were putting it in the buffer, we're also outputting it, which is obviously wrong. Okay, so let's not do that. That's definitely a mistake. All right, still got problems. Lots of time here. Okay, so now let's look here. We got expected to contain hi space exclamation mark, but okay, so that's interesting. So we're missing this hi here. That is, it didn't print out the word when this hi here got dropped. Okay, so why did that happen? That hi happened when we got to the end of a word. Okay, so it wasn't alpha. Oh, I see. Because, all right, so it happened here. If it's alpha, sorry. Okay, so here we're just dumping the buffer out. And, all right, so if we got an exclamation mark, we need to do this stuff. Okay. Else we need to dump. We need to do this. Need to dump everything out. Okay. We didn't dump out. So this little hi here didn't get printed out because we didn't dump it out. I'm sure I could write this a lot more neatly if I, there we go, we've passed it all. Okay, so that I didn't do that very gracefully, I apologize for that, but let's just run through this one more time. I'll run through it from the top down because I didn't do that very gracefully. So what are we trying to do here? First of all, it said to simply read in a file and print and read it in and write it out. We did that very simply at the start in the example I gave you at the start. Then the next one was, okay, let's do that with some more complicated conditions. So let's, if the caps thing is true, then we need to store things up into a little buffer. And then if the word gets finished with an exclamation mark, then output it with uppercase. Otherwise, just output it, okay? And so we've stored it all up here, and that's what's going on here. So if it's an alphabetical character, and we haven't filled the buffer up, then keep adding it to our buffer. That's what's going on here, as long as we haven't filled the buffer up. So that's what that is. And this is, okay, if that's not true, then we must have either we've got an alphabetical character, but obviously the index is too big, so dump the whole thing out. Otherwise, if we've got an exclamation mark, it means great, we finished a word. If we've got an exclamation mark and there is stuff in the buffer, that means we finished a word, which is great. Otherwise, we did not finish a word, in which case we just dump the whole thing out. All right, so I'm sure I can do that code better than that, but that's basically it. Any questions on that, that question? I'll recap what I think this question is really about. This question was really about the basic stuff we did in the last lecture on how you do file I/O, where I copied one file to another file in the last lecture. And it's also a little bit about buffering, because really what's going on here is we're creating a little buffer to store things in, so we can look, store things up, see if some condition holds, and then change what we do with the stuff we stored out according to what happened later, which means we need to store things before we print them out. This would be way easier if you got to print everything out as you went. But the question is deliberately made a little bit more tricky by saying you don't get to print stuff out until you've looked a little way ahead, which means that you need a buffer in which to store stuff, and only when you get to a certain condition can you know what to do with the stuff that's in the buffer. So that's a little bit subtle. All right, now let's have a go at Bishop. Bishop is hard, definitely hard. I'm going to start trying to solve Bishop right now, but I highly doubt I can do it in the 20 minutes we have remaining, because it is a hard question and I want to explain it to you as we go along. So what is the question? The first thing is, remember you need to budget time for these. If you don't think you're going to get there, then don't waste time on it, because you're going to have to read the question carefully to understand it. So first of all, you've got an 8x8 chessboard, so hopefully you know roughly what a chessboard looks like, and you've got coordinates which represent the location of a black bishop. You actually don't need to know anything about chess to answer this question. That's not what it's about. Okay, you need to calculate the number of black bishop moves for a given situation. In a minute, we're going to hear what a black bishop move is. Okay, so now there's our board. You can see the board here. It's 8x8, and they're numbered like this. Okay, black bishop moves is a number that represents the smallest number of consecutive moves, uninterrupted by any other player, it takes for a black bishop to reach a white chess piece. There's no way to, if there's no way to find a white chess piece, then the black bishop moves is -1. Okay, so it means you can't find one. If the bishop can reach a white piece in one move, then the black bishop moves is 1, and so forth. Okay, each move, the black bishop can move on any one of the 4 diagonals. Okay, so if the black bishop was sitting here, it can move up on this diagonal, or down on this diagonal, or up on this diagonal, or down on this diagonal. Okay? Where was I? Until it reaches the edge of the board, right? It can't go off the edge of the board. A black piece or a white piece. And it says here the black pieces are the stars and the white pieces are the circles. Okay? So if it reaches a black piece, then it needs to stop before it reaches it. So it'd have to stop at this place. And if it goes down this way, it would reach this white piece here. Okay, the types of chess pieces are completely irrelevant to this game, so you don't need to know anything about chess. All you need to know is there's a piece there. Okay, so you don't need to worry about what pawns, rooks, and queens and so forth are. They're not related to this. It's a very simple problem in terms of the chess. You don't need to know anything about chess. Okay, in this example, black pieces are indicated with a star, white pieces with a circle, empty locations are marked with a dot. Okay, so all the dots are empty locations. if the above board was given and the black bishop was at C8, so let's go to C8, it's right in here. If it was there, so it's over the top of that one, that's a black bishop there, then the black bishop moves would be -1 because the piece at C8 can't move. The two upper diagonals, that way or that way, we go off the board, and it can move in the lower diagonals, but neither encounters a white piece. So if it goes down there, it hits a black piece straight away. If it goes down there, it hit a black piece straight away. So in that case, for that example, the number of white bishop moves would be -1. If your black bishop was here, it could only go up there and off the board, up there, off the board. Here it doesn't, it hits a black piece. Here it hits a black piece, so it's -1. All right? Two lower diagonals, they're blocked. Okay, all right. If the above board was given and the black bishop was at F8, F8, it's up here, then the black bishop moves would be 2. Okay? From F8, the bishop can't move on the upper two diagonals. It can't go up this way and it can't go up that way because it'd be off the board. It can move on the lowers, but neither path encounters a white piece. However, so if you go down here on that diagonal, no white piece. You go down here on that diagonal, no white piece. Okay? However, if the black bishop moves to H6, H and then 6, then, so that's that diagonal there, then it can move take another move, and it can reach the piece at C1 on the next move. It goes down on this diagonal. So that's 2 moves. So it moved from here to here, it's 1 move, and from here to here and found a white piece, that's 2 moves. Okay? So it's 2 moves. So here I've drawn it there with little hash marks. Okay? So we call that 2 moves, right? 1 move to go there, so the bishop can keep moving until it hits something else. It either hits a black piece or white piece at the edge of the board. There are other ways to reach a white piece from the same number of moves. It could go to C5 and G1, C5, so it can go to C5 and then to G1 down there, like that. It's also a valid move, but that's also 2 moves. And B4 to C3 and so forth. Okay. So now the chessboard is represented as a string of 64 characters with a character dot representing an empty square, 0 representing a white piece, and star representing a black piece. The first element for the array is a square at A1, the next is B1, and so forth. Okay, the black bishop position is represented as a 2-character string that represents the chess position. For example, that or that. All right. So this is what we've got to work with. So the question is, what do you do now? All right, that took, I don't know how long that took. It took about 5 minutes to read through that. That's fine. If you want to really nail these questions, you're going to have to spend at least 5 minutes thinking through it. Now you need to think about how you're going to solve the problem. So this is a solver problem. People asked about how to do a solver problem. You need to think about a few things here. What information do we want? And probably we're going to have a recursive method. Okay? So what I would suggest is you want to have some basic state here. And I provided this for everyone. That's just to help you. Okay? What this does is takes a board string and will print it out just so you can use it in debugging. So if the test gives you out a board and you're like, what the heck is that? You can use this to print it out. Okay? So you can that's just for fun. It's not part of the question really. Okay. So what would you do to solve this? What I would do, first of all, when you do a solver, you often need a Boolean for each position to know whether or not you've been there before. So I would start off by doing that. I'd say static Boolean visited equals new Boolean 64. Right, and then I can do, then what I would suggest, to make this simpler, let's make an array of where all the white pieces are and an array of where all the black pieces are. Okay, so we say static Boolean black equals new Boolean 64, static Boolean white equals new Boolean white. I meant not while. All right, now what I would suggest we do is we write ourselves a recursive function that we're going to call. And what this is going to do is it's going to start at a particular position, and then it's going to with a given number of moves already done, and it's going to return how many moves it takes from that position. So, okay, so you saw here when we did this example, from this position here, it was 1 move. And from this position here, it was 1 move to there plus the 1 move to there. So that then it's 2. So you can think of it, this one here is exploring its possible places and then exploring its possible places here. What's interesting about the black bishop moves is that the number of moves we count here, that's 1 move, but you could stop, and you can stop and explore from each of these places. So it means in terms of exploring, we've got to explore from here, we've got to explore from here, we've got to explore from here, and explore from here. But that whole thing, if we end up exploring from here, that whole thing is only 1 move. Okay, that's a little bit subtle. So it's not 1, 2, 3, 4, 5 moves. That's 1 move because a bishop can go as far as it's able to. So you've got lots of, from this thing here, that's actually 1 move. That's 1 possible move. That's another possible move. That's another possible move. And that's another possible move. And they're all only 1 move in length. Okay, that's an interesting subtlety about this particular question. And it's worth thinking about when you write your answer to this. Okay, so just before the lecture, I had a go at solving this. And what I did is I wrote myself a recursive method, static black bishop moves, which took a starting position. So I just used the integers to represent the places on the board, so 0 through 63. Start, and then the number of moves we've done so far, right? So where's the example? So here at this point you've done 0 moves, at this point you've done 1 move. So when you call the method from here, the moves would already be 1. Okay, so start moves. Best is the best thing you've found so far. So if you're doing this exploration, if someone has already found a solution which only takes 2 moves, don't keep looking beyond 2 because there's no point, right? So it's finding moves that take 3, finding solutions that take 3 moves is useless if it's finding moves that 3 moves is useless if you already have a solution that takes 2. Okay. So and then the other thing is so we've got you want to know the best number of moves as well. The other thing you want to do is to not when you're exploring from a given point. When we're exploring from here, we don't want to explore in that direction. We want to consider that as 1 move. We don't want to say, okay, from here we can go to that one, to that one, to that one. Rather, we want to jump directly to that one. So when we're considering options from this place, we don't want to consider that as one of our options, okay? We want to go to that one separately, not count it as an additional move, okay? So we're going to, that's the way I approach it anyway. So we'll call it last direction. Okay, so this is going to, and we're going to return an int here, which is how long it takes. So static int black bishop moves. And then what we're going to do here in this one is initialize some stuff. So we will say, and one of the things we're going to do in here, by the way, the sort of thing you classically do, I'll just write some of the most important parts here. For a key part of this, we're going to say visited. And here we're going to recurse in certain ways. I'll write that code in a minute. But this is a very important part of the pattern. So what we're going to do is from where we are, we do not, when we do this exploration, this is exploration. When we do this exploration, we don't want to, we don't want our exploration to come back to the place we were, otherwise we can get ourselves into a loop. All right, so this is a very important idea. So now what we want to do here, so that's why we do this. All right. Now what we might want to do is say, the other thing we might want to say is, given a given position, is this next position valid? All right. So I'm here. Can I go to here? And what that's going to do is say that make sure that here is not off. So basically saying, is this next step okay? So first of all, make sure it's not off the board. Make sure that you're not hitting a black piece. Make sure you're not hitting a white piece, because you'll cover that here. So say something like this: if white start, then return true. Something like that. I think, or maybe it's moves plus 1. I have to think about that carefully. But you're going to have something there. So you shouldn't be visiting. Remember, our goal is to find the white one, right? So at that point, if the thing we landed on is white, then we hit the goal, okay? So what we want to do is not go somewhere if it's black, and not go somewhere if it's visited, and not go somewhere if it's off the board, and not go somewhere if we did a column wrap, okay? So let's quickly write that. We'll say static boolean, okay, and we'll say int prev, int next, okay? And then what we're going to do here is just going to say if prev, sorry, next is what we're interested in. Next is next an okay place, okay? So we'll say if next is less than 0, or next is greater than 63, then return false. All right, so that's an example of where next is not a viable place to go, okay? Another condition is if if black next, so that we're landing on a black piece, then we can't go there. Or if we've visited there in this tour, okay? So in either of those cases, we want to return false. And the other one we want to consider is when we do a wrap. We did the same thing in the boggle, if you remember that. So what we want to do there is you want to look at the difference between the columns. So if we did a row wrap, then that would show up by going below 0. You get a negative number. You get a number below 0 if you went off the top of the board, and you get a number greater than 63 if you went off the bottom of the board. So they're covered by that first line up there. So now what we're concerned is with if you go off the left or off the right. So this is off top, off bottom, and then the other thing we want to consider is maybe logically write this here. We'll say if we want to find out what column we're in. So we'll say so like the absolute value of the difference in the two columns. So the column of the next and the column of previous, the absolute value of that should be 1, right? So it should only be one column different. If it's more than one column different, then you must have done a wrap. Okay, so if next is here and previous is here, then the column numbers won't be different by 1. Okay, so it doesn't matter which way around, if it's positive or negative, it doesn't matter, but they need to be only one different. Okay, so we'll say that if math.abs, and then we're going to say, what is it? Prev 8 minus next 8. So that's the column numbers for the two. Let's put parentheses around here to make sure this is sound. Okay, so now we've gone, we're looking at the absolute value of the differences here. If that is equal to, if that absolute value is not equal to 1, then we return false. Right? So, and I'll write a comment there to make that clear. That's if we're off the left or the right. Okay, so this, we've now got the bare, otherwise we return true because it was sound. Okay, so if none of those things happen, then we're good. Okay, so now we've got ourselves a little method that helps us navigate around. The other thing we want to do is we want to be able to write ourselves some code that allows us to explore. Now, if you remember in the Boggle thing, we had lots of different places we can go. For the bishop, it can only go to 4 places. It can go to there, there, there. With Boggle, it could go to 8 places, if you remember that, right? And we made a set of all the different places it could go, and we calculated the difference. So here, we can calculate the difference also. So from here, it can either go there, which is what? What's the difference in terms of the position on the board? If you think about it, the difference between here and here is exactly 8. So that number there is minus 8, right? That's minus 8. That there is minus 9, okay? That there is minus 7. That there is plus 7, and that is plus 9. So that's the 4 differences we can do. You could think of that as a stride, okay? So that's a stride that we can do. So Right, now what do I want to do here? Right, okay, so we're going to do that. Now, the other thing we want to do here is short circuit stuff if we've already got to, if moves is equal to best minus 1, moves is equal to best minus 1. If moves is equal to best minus 1, then the next move is useless because it won't match the best. So we'll just return minus 1. It means there's no point in further exploration, right? Right, so if we couldn't find it on this move, then it means you've got to do at least one more move. And if that would take us to the best, then there's no point in continuing. Okay, so we return with minus 1, so this is fruitless. All right, now what we're going to do is we're going to say what are the places we can go. So this is now the exploration part. We'll make ourselves a little array here. Int, we'll call it, I don't know, strides. Strides, and then we'll say minus 7, minus 9, 7, 9, and that they're all the different places we can go, right? So from where we are, okay? And what have I done here? Oh, it's an array. Okay, so they're all the different places. Now what we're going to do is we're going to go from where we are to each of those. Okay, so for each of the strides, so for, what's the time? I'm going to closely watch this time. I do not want to run over today. For int stride in strides. Okay, what we're going to do is go to all of the different places that we could go to, but we don't want to go to continue in the same direction that we were going in. So we'll say if, we'll call it last stride up here, this guy. If, then do the following. Now what we want to do is we need to have a do loop which will go down our path. So we're going in a particular direction. Maybe we call this direction. Let's just change the name of this to make it a bit more clear. Any questions there, by the way?
No, not really.
Okay, all right. So what we're going to do now is we're going to go, as long as that's not true, we're going to do a do loop through all the things until we can't go any further. So do something something while okay something like that. Okay, so we're going to keep going as long as we're allowed to go to that place given where we currently are. Okay, and so we need to now so something like here we want to start off with so start, we can make a, okay, so we've got start there as a variable up here, which is where we started off this entire exploration, and now we can make another one in here. So that's where it'll begin there, and it will slowly move. Next, we'll slowly be advancing. And then we can say...
Hi, Steve.
Yep.
Question pop up from Hoya. Should we return best in line 111? So line 111.
Yeah.
Shouldn't we just return, best? Because -1's in case that.
Yeah, that's a good question. So the question was, should we do here or just return best? Yeah, in some ways -1 is a better answer, because -1's saying we're not going to get anywhere here. It's not going to help us. Okay, if we return best, it implies that, yeah, this was just as good as the other one, but we don't know that. But it probably doesn't matter. That's a good question, and I think the answer is it really just doesn't matter. Yeah, it really just doesn't matter there. Okay, so Now what I'm going to do here. Okay, so now what we want to do is you want to say if I'm going to have to stop. Oh wow, I'm already over time here. So what I would like to do here is what should I do with this? I'd love to show you the rest of this. Maybe what I can do is I can record this offline. I don't want to hold the lecture up because I really want to finish today's lecture on time. I'll record this offline and post it on YouTube with the other stuff. Okay, that's probably the best thing to do here. All right. So with that, any questions there, Leo?
Yep. One from Alan. What do the numbers in the DIR's array mean?
Yeah. So this is those numbers. What this is. I'm answering the question by typing a comment in. So if you think about the grid with everything numbered from 0 to 63, then that's what I was trying to explain up here. So if you're in this position here, you can go 4 places. You can go here, 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 and here. Okay, 4 places you can go. Now, if you do the math and work out the number, this is position 0 and this is position 63, then you can go, that's going to be minus, to there is minus 8, so that's minus 9, that's minus 7, that's plus 9, and that's plus 7. Okay, so it's just like I did in the Boggle example in class, these are the distances to each of the positions that we can go to. All right? Any other questions there?
No, I think that marks the end of the chat. Yeah.
All right. Well, with that, I will finish up, folks. It's been a great semester. I hope you all do well in the exam. I'll be happy to answer questions on Piazza. I will try and finish off that. I've got to run to a meeting, actually. A seminar, actually. So I can't run overtime today. But I will try and post the rest of the recording to YouTube so that you can see how I work through the rest of that problem. And then what I'm going to do is we're done. Like, that's it. That's it for the semester, folks. So this actually is a bit of a big deal for me because I have been teaching this class. You're the 10th year I've taught this class, and I'm not teaching it next year. And almost certainly if I teach something else, it won't be this class, which is very sad. Someone else gets a chance to teach you great people. And maybe I'll get a chance to teach you at a later year. Maybe I'll be teaching you in a class you do later on. But you've been a great class, and I just want to say thank you to you all for being a great class. And with that, I'm going to finish up. One thing, I've got a tradition here, and that is I try to condense the entire course into my revision lecture. And the way I do that is by running a quick video, which I'm going to show to you now. And after I finish the video, we'll finish the streaming. So thank you all. And feel free to ask me questions on Piazza. And other than that, I'll see you later, and really good luck in the exam.